Welcome to aminacademy.com. In discrete mathematics, let us discuss about integer representation in computers. In our everyday life, we use decimal notation to express integers. Whenever we enter data in a physical file or a paper, there is no complication in how it will be represented there, because what you wrote in paper, it will be there itself as it is. However, the case is not in same in the case of computers because the applications are different. For example, the representation of a real and integers in computers involves significant approximation and a deeper understanding of essential digits concerning how the mathematical operation will proceed. Simply we are entering the buttons in the computer, we are entering some numbers, letters, but its process is very big in the computer, but it is very fast and accurate. Representation of integers in computers. In computer science, integers are presented in the form of binary digits. It also refers to its value and representation because it depends on how it is stored in the computer memory. A typical data set in a computer depends on the minimum and maximum possible value derived from it. That means each and every typed instruction, there is some minimum and maximum possible value for it. Although the order of memory bytes differs, a specific data set in a computer always has a difference in its minimum and maximum possible value. There are two major types of integer representation: unsigned integers and signed integers. The most common representation of integers in computer science is expressed in a string of bits. The width and accuracy of an integral type depends on the number of bits in the representation of integers. On the other hand, there are four methods to represent signed numbers in a binary computing system, that is decimal, binary, octal and hexadecimal. But some other computers language also define integer size and representation through manual methods that are machine independent. The other perspectives have different definitions, depends on the processor word size, leading to a different representation of integers in computer science. Therefore, the representation of integers in computer is different from its expression in mathematics. So it is necessary to understand the critical elements involved that make this difference possible. Representation of integers on different bases. In computer science, integers can also be represented on different bases. For example, if we change the number to base 10 from another base, we need to break down their values. For instance, if we have to change the numbers 5763, we will have to break it down and return as it is, as like the given. Look at 5867 can be represented as 5000 plus 800 plus 60 plus 7. Further, 5000 is 5 into 10 power 3 plus 8 into 10 power 2 plus 6 into 10 power 1 plus 7 into 10 power 0. Each position have its own values. If we notice the above pattern carefully, the digits corresponding to the existing coefficients on the power of 10 are brought together to get the final value. Like if you simplify this value will come. Suppose if we enter this number, it will follow this way and further expressing in the computer itself. Similarly, we can also specify numbers in other bases except 10 or the representation of integers in different bases. Here we express this at base 10. This number can be represented in other bases also. We will discuss details in further videos. In this case, we must add the value together to get the final value using the different digits corresponding to the coefficient of powers. In that order, every number will have the base for its representation, but no more than one such representation must be done using only the digits 0, that is 0 by b1 in any given base number is recommended. Now we'll do some example to how to convert one number from decimal to binary, octal and hexadecimal, different bases. First, consider the number 485 in decimal. 485. This 485 can be represented as 4 into 10 power 3 plus 8 into 10 power 2. Now 4 into 10 power 2, it is 2, it is 1, then 5 into 10 power 0. So how to convert this 485 that is in base 10 to binary, that is base 2? We have to convert this number. Look at here, this is a process. Suppose I write 485, we have to process in log division, divided by 2 because base is 2, which is 242. The remainder is 1 because 242 into is 484, remainder is 1. Here divide by 2, 121, remainder is 0. Here another 2 is divide 60, remainder is 1, and another is 2, 30, remainder is 0, then 2, 15, remainder is 0, 2, 7, 1, 2, 3, remainder 1, 2, and 1, 1, 2 are 2, and remainder is 1. So now we have to write this order like here. Therefore 1, 1, 1, 1, 2, 3, 4 ones and 2 zeros, 1, 0, 1, base 2, which is equal 485. 485 is decimal and decimal representation. This is a binary representation. That means, suppose, imagine if you enter 485 to the computer, it's stored in this way, that is 1, 1, 1, 1, 0, 0, 1, 0, 1. This is represented by 485. This big process is being done inside the computer, but it's very fast. That means storage area is like binary. Next, convert in octal. Same number, let us convert in octal. 485. We have to convert in octal means divide by 8. If divide by 8 is 60, 480, the remainder is 5. Another 8, 8 sevens are 56, remainder is 4. Further, we cannot divide because it is lesser, that 7 is lesser than 8, so we have to represent 745 like this. 745 base 8. This 485. In some computers, this octal memories are there, octal representation. Now hexadecimal. Hexadecimal means about 16. Same 485. First it is 16 is 30. 480, then remainder is 5, another 16, the remainder is 1/16 or 16, remainder is 14. So we have to 1, 14 and 5. Here this 14 is double digits. We have to convert this octal digit. For octal digit, 14 is represented by, because 10 is 9, up to 9 is normal decimal numbers. Then here 10 become A, 11 become B, 12 become C, 13 become D, 14 become E. So which is 1 E 5 base 8, which is 485 base 10. So we consider this 485 as 1E 5 base 8. Like this, we can reverse conversion also get. That means we can convert this 745 octal base, convert to this reverse order also. We will discuss in future videos. Counting the numbers in another basis. Counting in other bases is not much different from counting in base 10. However, if the requirement leads us to add another base without converting to base 10, you can easily count the numbers. It is only possible as long as you carry the sum greater than or equal to the original bases. That means you have to convert suppose different basis numbers are there, you have to convert all of them in single one basis. That means base 10 or base 2 or 8 or 16, then add, subtract, multiply can do. In such cases, changing numbers from one place to another often leads to erroneous cases that can lead to significant errors in the calculation. Hence, it is necessary to take note of the value before arriving at the final value of the calculation. So far, we discussed about integer representation in computers. It's interesting field. Nowadays, the computers are very much useful. Without computers, the man cannot live like it become like. So, you have to understand further details in forthcoming videos. Please wait. If you have done, please subscribe our YouTube channel.